this video, we're going to look at the second derivative test. The second derivative test is an easy way for us to test to see whether a function has a local minimum or a local maximum at the critical points. It's very simple. What we're going to do is we're going to start with two simple steps. And the first step that we're going to do is we're going to just take the first derivative so that we can find the critical points. After you've taken the first derivative, we're going to take the derivative again, aka the second derivative, and we're going to plug our critical points into that second derivative. Now, once we've plugged our critical points into the second derivative, we're going to have one of three things happen. We're either going to have f double prime of x be greater than 0. So if our output is greater than 0, we're going to be concave up, which means that we have a local minimum. We're going to have f double prime of x either equal to 0, and if we have it equal to 0, then neither one is a local, we neither have a local min or a max. We could have a potential inflection point. And then finally, if the output of f double prime of x is less than 0, that means that we are concave down and we have a local maximum at that critical point. So let's jump into the first example. So this first example, we have f of x equals x cubed minus 6x squared plus 9x. And I want to find the local max and min. And we can eventually see if we have an inflection point. Sometimes we'll get that out if we have f double prime of 0. F double prime equals 0 when we plug in the critical points. That'll be in another video for actually testing for the inflection points, so check that out. But for this video, what our steps are going to be is we're going to first take the first derivative here. So when we take the first derivative of a polynomial, it's very simple. It's just going to be a power rule for each one of the terms. So we have 3x squared minus 12x plus 9. I'm going to set this equal to 0 so that I can solve for my critical points. So we have 3x squared minus 12x plus 9 equals 0. And I can factor a 3 out of everything here. So pull the 3 out, I get x squared minus 4x plus 3. And we see that that's easily factorable so that we have 3x minus 3, x minus 1 equals 0. So here we can set all of our factors equal to 0. So we have x minus 3 equals 0, x minus 1 equals 0, and we get x equals 3 and 1. So these right here are our critical points. Now, once we locate our critical points, I want to use the second derivative to test to see if we have a local min or a local max. So what I'm going to do is I'm going to take the derivative of the first derivative. So we're taking the second derivative here. So f double prime of x equals, well, 3x squared when we take the derivative is going to give us 6x minus 12. And that's it. Super simple. So we have our second derivative here. And now what I'm going to do is I'm going to plug my critical points into my second derivative to see whether or not we are matching these three ideas up here. All right. So I want to plug in f double prime of 1, and we're going to plug in f double prime of 3. So plug in f double prime of 1, I get 6 times 1 minus 12. Well, that gives me 6 minus 12, which equals negative 6. All right. We'll evaluate that in just a moment. And actually, let's give ourselves just a little bit more room here. F double prime of 3, I have 6 times 3 minus 12, which equals 18 minus 12, which equals 6. So since f double prime of 1 equals negative 6, that negative number tells me that I have a local max. I am concave up. Then when we look here, we can find that since f double prime of 3 equals 6, I know that we have a local minimum because 6 is greater than 0. So we have a local minimum, and we are concave down. And that's your second derivative test. So I hope now you feel more comfortable with the second derivative and utilizing the second derivative test to find whether or not we have any local minimax of our function. So thanks for checking out the video. I'll see you next time.